So electrophilic addition is going to happen whenever we have carbon-carbon double bond. So it's going to be very exclusive for unsaturated compounds such as alkene. So we have four types of electrophilic addition. Okay, one is going to be when you have carbon-carbon double bond added with H2. Okay, and we have carbon-carbon double bond added with steam. We also have, okay, carbon-carbon double bond, okay, subjected to H hex, okay, hydrogen halides. Carbon-carbon double bond subjected to halogens. Okay, so they have their own mechanism. Okay, they have their own condition. Okay, so which we will learn later. But generally, what we are going to have is going to be the double bond is going to be broken, and you are going to have a saturated compound which has, okay, the H will come over here. Okay, the H is going to come over here and another H will come over here. This is addition. And then if you look at the for addition with steam, you are going to get same, okay, saturated. The double bond is going to be broken. So one of the H will come here, another OH will come here. Here, let's say we are going to take replace this HX as HCl. Okay, so what I'm going to have is going to be similar, saturated. The double bond is going to be broken, and then you are going to be added with one of it will be H, another one will be Cl. Here, let's say I'm going to take it as Cl2. I am going to have, okay, something like this, all saturated, and then one of it will be Cl, another one is going to be Cl. This is addition. But it is very important to look at the conditions. Okay, the conditions where this happens. Okay, we are going to write it over here. The conditions for addition of hydrogen is going to be with the presence of nickel catalyst and 140 degrees Celsius. And the condition for addition of steam is going to be with the presence of concentrated phosphoric acid. Okay, concentrated phosphoric acid with the high temperature of 330 degrees Celsius and 6 megapascal. Okay, that's going to be the condition. For HX, okay, it must be done with concentrated HCl, okay, concentrated HBr, concentrated HI, depending, okay, concentrated, and it is done under the room temperature. Okay, I'll put it as RT. And here, okay, chlorine, bromine, and iodine, okay, is going to be aqueous condition, okay, and then it is done under the room temperature as well. I think one thing to note is going to be if we are reacting, okay, with Cl2, okay, especially when we are reacting with Br2. The Br2 is orange in color. In comparison to free radical substitution, electrophilic addition happens in a very reactive manner. Therefore, the orange color of the Br2 will be decolorized immediately. Okay, and that is going to be the difference if you compare with a free radical substitution. So we have done all this, okay, and then what I want to teach you over here is going to be the mechanism of the reaction. So I'm going to teach you using two examples, okay. I will use carbon-carbon double bond, and I'm going to use Br2 as an example, okay. Another example later that I will use, maybe I will react with HBr. Okay, so now, okay, if I look at this, okay, I will see that, okay, I will see that, okay, first, okay, Br2, they are non-polar. So how do we show that they are going to have partial positive or partial negative? Yeah, when they come near to the double bond, okay, there's a lot of electron. The electron will repel the electron that is inside the Br to go to the other side of the Br. Okay, that is how we get the partial positive charge and partial negative charge. The explanation. Okay, that is, it's not polar, but the electron and electron repulsion makes it in that way. And next is going to be, there is a small difference over here when we draw the curly arrow diagram. Do remember the arrow that I draw, it's going to show us the movement of the electron. So you can see the movement of electron from this part to Br. And you see here, now the electrophile will attack the double bond. Okay, but I don't go and put the electron, the curly arrow towards like that. That is wrong. Okay, you need to put the curly arrow to show the movement of electron, and electron, they are here in the double bond. So they are going to be represented in this way. So do remember, we don't break them. Okay, we don't do the heterolytic fission yet. Because this happens, now the heterolytic fission will happen, which is going to be, you are going to have, okay, if I put it here, you are going to have the double bond broken, and then Br will come here. Okay, the electron that you have, okay, is going to go directly to the formation of the bond with carbon and Br. So that is going to make that this carbon become positive charge. So you are going to have a carbocation, and left with the Br, which is going to be the nucleophile of the Br. Okay, so this nucleophile of the Br is going to be attracted towards positive charge, because nucleophile, they are attracted to positive. So the electron, okay, do see where do I put the curly arrow, is movement of electron. So I put it in that way, and it is going to give you this molecule. So it's going to be, you can see the mechanism of the reaction, okay, involving how many curly arrow. You can see, okay, one curly arrow, two curly arrows, and three curly arrows. Okay, very important. Now, how do I show this, okay, related to, let's say, carbon-carbon double bond, and I am going to show with a reaction with HBr, for example. Okay, the mechanism is still the same. Okay, it's still electrophilic addition, but now it's going to be different because it's a polar molecule. And Br, okay, being electronegative, the definition of electronegativity is the ability of the atom to withdraw or to pull the bonded pair of electron, or the covalently bonded pair of electron to itself. So according to that definition, this automatically goes there. So the difference is, they do not need to approach the carbon-carbon double bond. It is already delta negative and delta positive. So when this happens, okay, there is going to be additional step that is going to happen, which is going to be, you are going to get H plus, and you are going to have Br minus over here. Okay, that is this is heterolytic fission. So you take note why there is electron, two dots, and why there is no dot over there for H plus. So this H plus is the electrophile, okay, and the Br minus is the nucleophile. So what is going to happen next is going to be, this double bond will be, okay, the electrophile will attack the double bond, but when you show the curly arrow, okay, be careful, it's showing the movement of the electron. So you are going to get, okay, the double bond is going to be broken. So H will come here. And because the electron went to form the bond between carbon and hydrogen, so the carbon will become positively charged. So you are going to get a carbocation, and left with the Br dot, which is going to be your nucleophile. Now what's going to happen? This is going to go there, and you are going to get this molecule. So this is, again, you can see how many curly arrows that we draw. 1, 2, 3. Still the same. But what's the difference? Okay, the difference is I show the heterolytic fission. And here, okay, for Br2, I do not show the heterolytic fission. Okay, here I'm showing the heterolytic fission. Okay, that's the difference. Okay, that's the difference. Okay, but this method, okay, that I draw over here will be applied because we know that there are 4 reactions. One is going to be H2. Second is going to be addition with Br2 or X2. Okay, I'll put it over here. 2 is going to be X2, which is going to be similar with the Br2. And then third is going to be HBr. And then fourth is going to be HOH. Okay, steam. You can see that, okay, these two, okay, the one that I show for Br2 can be applied for H and H as well, hydrogen gas. Okay, if I want to write down, okay, the same mechanism, similar way, okay, so I will just leave it over here. This one is the same way. And then if you are doing this, okay, for HOH, okay, this is going to be the same way. Okay, how we show for water, the mechanism is going to be the same as how did I show for HBr. Okay, that's the difference. Now